Okay, for example, for lighting, we choose 0.8. Okay, 0.8. Aircon 0.5. Just estimate the usage of every day in your lifestyle. And then the water heating 0.3, ceiling fan 0.8, refrigerator always on, so 1, lift 0.5, booster pump that we need is around 0.5. Okay, so we look at these examples. So example, an apartment consists of, okay, we have fluorescent lamps with 40 watt, ceiling fans with 60 watt, 13 amps socket outlets with 250 watt, one numbers of water heater with 3000 watt, one numbers of 1 horsepower air conditioner. So from here, the questions is determine A, the total maximum demand, B, the maximum demand, C, the maximum current, D, the size of the MCB, E, size of the RCD, and F is the electrical wiring schematic diagram. Okay, how to solve this problem? So this is the layout plan. Okay, so normally the layout plan of the house. Okay, you can see here there are 3 bedrooms. Okay, 3 bedrooms here. We have the toilet here, the living room here. Okay, and then we have the kitchen here, right here. So you have to count first how many light points there. Okay, how many ceiling fan. So if we look at here, the fluorescent lamp, okay, the lighting point is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 light points, okay. So we have 12 light points. And then how many ceiling fan? 1, 2, 1, 2, 3, 4. So we have 4. Okay, so we have 4 ceiling fans. Okay, how about the SSO? Okay, so you have to look here. 1, 2, right? 1, 2, 3, 3, 4, 5, 5, 5, 6, and then 6, 7, 8, 9, 10. Okay, so we have 10 SSO. Okay, so we have 10 SSO. Okay, and then 1 number of water heater and 1 of air conditioner. So from there, you have to come up with the load calculation. Okay, first you have to come up with the load calculation. This one is the load calculation. So load calculation is very important in order you to design the electrical system. So you just put here. So in this table, you can do it in the table form to be more easy to you to monitor. Okay, to calculate the total maximum demand. So first, you have to write down the numbers, description, quantity, estimated power, the total connected load. Okay. So you have to calculate the total connected load, or TCL. TCL is the quantity. Okay, the quantity you multiply with the estimated power. Okay, for the lighting, so 12 times 40, you get 480 watt. And then this is demand factor. Demand factor, as I mentioned before, is based on the assumption. So for the lighting, we assume that we use 80%, which is 0.8. Then you can calculate the maximum demand for the lighting is TCL. Okay, so this one is TCL you times with the demand factor. Okay, to get the TCL, okay, you have to calculate quantity you times with the power. Okay, then you proceed with the ceiling fans. 4 ceiling fans, you times the 60, you got 240 times 0.8, you get 192. Then you continue with the others. Okay, and then aircon is 1 horsepower. So 1 horsepower equivalent, we assume that 750 watt. That's why we times 1 times to 750. So you got 750 watt. So if this one is 1.5, then you have to times 1.5 times 750. Then you calculate, you times with 0.5, you get the maximum demand. So the total maximum demand is the summation of all the maximum demand for the electrical appliances. Okay, so this one all you sum up, you get the total maximum demand. Okay, and then you have to find the maximum demand for this house is MD equivalent to TMD, you times with the coincident factor. So this coincident factor, you have to refer the book from TNB ESA. Okay, ESA. You know what ESA, right? Electricity Supply Application Handbook, TNB. So if you look at the TNB ESA, for the residential, we use TNB use 0.9. So in our calculation, you have to use 0.9. So you got maximum demand for this house is around 2,790. So near to 3 kilowatt. Okay. So this one is the detail of the calculation. So how to calculate the TMD, total maximum demand, and then how to calculate the maximum demand. Then you have to calculate what is the maximum current. So maximum current is by using, because this one is the single phase, we just use the equation P equals to IV cos theta and I equals to P over V cos theta. Okay, use this equation, then you can get the maximum current. From this maximum current, we can determine what is the current rating of the MCB that we want to use. Okay, so by using this equation, okay, 1.25, we times with the maximum current, then you can get 17.85. So approximately we can use 32 amps MCB single phase. Okay. And then for the RCD, as I mentioned before, the RCD must equivalent or larger than the MCB. Okay, so you can directly choose 32 amps also for the RCD or RCCB. Okay, so and then you have to divide by 2. We have here 30 milliamps for the power circuit, the sensitivity, and then for the lighting circuit we use 100 milliamps. And then you also have to consider, for example, for the water heater, you use this. Okay, and then this is the electrical. Then we can see the electrical wiring schematic diagram. Okay, for the electrical wiring schematic diagram, so what we have here is we're starting from the TNB meter. Okay, this one is the TNB meter. Then we go to the MCB, single phase, 32 amps. This is based on our calculation. Okay, and then as I mentioned before, for the main circuit, we use 16 square millimeters for the cable. And then we have to separate the lighting circuit and the power circuit. Okay, so it depends on the company, the consultant company. Some of the company prefer to combine, and some of the company prefer to separate. So separate, I choose to use the separate because it is easy to do the maintenance for the system. So actually this is the DB, the distribution board. Okay, the distribution board of your house. Okay, so this is called DB, or the distribution board. From the incoming, which is the TNB meter, coming into your DBs and to the loads. Okay, so for the lighting circuit, then after connect with the MCB, we connect first with the RCD or the RCCB. So RCD and RCCB or RCCB, the current rating is equivalent to the MCB, or much more bigger than the MCB. So but for here, for this solution, I just choose the same as the MCB. But the difference between the lighting and also the power is the sensitivity. This one, the sensitivity. So the sensitivity for the lighting is 100 milliamps, and the sensitivity for the power circuit is 30 milliamps. So for the power circuit, must choose more sensitive because this load is near to the human being. Okay, for the lighting, okay, so as we can see here, for one MCB, we can connect approximately until 10 electrical appliances. Okay, that is the limitation. So you can calculate what is the rating that can be used for these types of MCB. Okay, so basically for this question, so you use for the first circuit, we use 6 numbers of lighting point plus 1 numbers of ceiling fan. The second one is 4 numbers of lighting point plus 2 numbers of ceiling fan, equivalent to 6 electrical appliances. Then we have 2 numbers of lighting point plus 1 number of ceiling fan, and then we can add more for the spare. Okay, in case in the future we need to connect more the electrical appliances, then we can use the spare one. Okay, so the sizing for the conductor, we choose 1.5 square millimeter. Okay, and then for the power, so for this one, for the lighting point, normally we consider lighting and also fan. Okay, and the power side, we consider 13 amps SSO. Okay, and then water heater, and then air conditioner. Okay, so for this one, for the power side, we have to consider maximum 3 numbers of 13 amp SSO for one MCB. Okay, so for example here I choose 2, 2, 2, 2, and then here is also 2. It depends on you lah. For example, if you want to use here is 3, and then 3, and then 2, and then 2. So it depends on your design, but you have to consider economically viable. Okay, and then you connect the water heater. So you have to put additional RCCB or RCD here. So the sensitivity for the water heater is 10 milliamps, more sensitive because it is near to the human being. Then you can connect with the aircon, okay, and then 2 spares. So this is all the electrical wiring schematic diagram. Okay, so this is the flow chart for wiring installation in building. Okay, when you get the project from your boss, this you have to do the site visit. There are 2 types of meetings that you have to attend. The first one is the client coordination meeting, and the second one is the technical coordination meeting. So normally for the client coordination meeting, you have to meet with your client, and then the client will tell you what they want, what they require for this project. Okay, and after that, you will do the work. Then every depends on the management, either to do the technical coordination meeting maybe once a week or fortnightly. It depends on the decision of the top management. Okay, and then after you go for the site visit, you see you see the site for the project plan. Then you have to deal with the architect. Architect will give you the architecture layout plan, and then you have to look on that particular plan, and you have to specify what is the equipment that you need for this project. Okay, from there you have to calculate the maximum demand. As I mentioned before, you have to calculate the maximum demand. You have to identify what is demand factor. You have to calculate the total connected load. You have to identify what is the maximum current, and so on, in order for you to identify what types of system that you want to use. Example, either you want to use the single phase or three phase. And then also you also have to identify what types of distribution substation that you need. Either you need to use the single or double chambers. Okay, one transformer or two transformers. It also depends on the load calculation that you have done. Okay, and then after that, you also have to, as an engineer, you also have to submit um, some of forms, okay, some of documents or forms to the authority for approval. Okay, so the authorities in your project normally is Tenaga Nasional Berhad, TNB. That one is more the electricity parts. And then we have the City Council. Yeah, the City Council is more on the street lighting and so on. And also the Malaysian Communications and Multimedia, MCMC. That one is for the telecommunications. But for the wiring installation, you are being you must focus more on the Tenaga Nasional Berhad, which is for the electricity part. Okay, so you have to submit three documents, which are the kebenaran merancang, okay, and then planning permission, kebenaran merancang pembangunan, and then you have the perancangan bangunan. That one is the building plan. Okay, after you have got all the approval from the authority, then you can start with the work execution. Okay, work execution. You can start with the work execution, and then you also have to do the inspection and testing of the work. And then after that, you have to submit the completion. You have to report to the authority. You have to sign the contract and also depositing the fees for the TNB, which is the charge sambungan pengguna CSP. And then after that, when the TNB receive the fees from you, then the authority, which is the TNB, will install the TNB meters and also will provide the electricity for you. So that's all for chapter 2. Inshallah, we will continue with chapter 3. Thank you. Assalamualaikum warahmatullahi wabarakatuh.